Hey class, this is Gigi. Going over exam 3 review number 6 and number 7 here. And it has to do with continuity, the concept of continuity. So the definition of continuity will say that a function is continuous at point A if the limit as x goes to the limit as x goes to a of f of x is equals to f of a. In this case, it means three different things. One is f of a exists, meaning there is a point right there, and then there has to be a limit. So the limit exists. And then finally, if there is a function value and there is a limit, then the last thing to check is that limit the function value? Okay, so those are the three conditions that must be met in order for something to be continuous at a point A. So keep those in mind. You will see then that the limit well, first of all, f of a doesn't exist for that function f of x, right? Condition number 1 fails. So the function is not continuous, okay? So f of 5 does not exist because when you put in 5 here, the denominator is 0. Okay, so the function value doesn't exist. And also that if we were to take the limit as x goes to 5 from the left, then your function is going to equal to 1 minus approaching 5 from the left, then x minus 5 is negative small, so that is negative infinity. However, when you take the limit as x goes to 5 from the right, f of x, this is going to be 1 over positive small, so it is going to positive infinity. So limit as x goes to 5 of f of x does not exist. So there's no function value, there's no limit, and so there's no way that this function right here is continuous. This is definitely discontinuous at x equals to 5. Okay, now part B. Consider the function here at a equals 4. Okay, so first you would check what is f of 4. Well, f of 4 is 9, so that's good. The first condition is met. Okay, now the second condition would be to go ahead and look at the limit as x goes to 4. And so in order to find the limit as x go to 4 of f of x, we need to consider this limit here. X squared minus 16 is x plus 4, x minus 4. And so we can see that the x minus 4 will be divided out. So then this is going to go towards 8. Okay, so when x is approaching 4, the limit is equal to 8, which is not the same as 9. So not the same as the function value. So the f of x is discontinuous at x equal to 4. However, it is a removable discontinuity if we defined f of 4 to be 8 instead of 9. Okay, meaning this right here, if we just make it 8, then our function will be continuous, and that's what it means to be removable. Okay, so that is number 6. Now let's move on to number 7. Number 7 says what is the value of a, so that our function is going to be continuous at 1. Well, we know now in this problem, actually G, not F, so used to writing F, G of 1 is a, right? So that value is defined, whatever a might be. Okay, so that's what we're looking for. Now, we need to confirm that limit as x goes to 1 of f of x actually exists. So let's go and take the limit as x goes to 1 from the left and limit as x goes to 1 from the right. So limit at x go to 1 from the left, we are on this branch of the function. So we are looking at 5x minus 2, which equals 3. Okay, now approaching 1 from the right, we are looking at this right here, or looking at ax squared plus bx. Okay, and we want this limit, and this, so when you plug in 1, you'll get x plus b, right? So in order for the limit at x equal to 1 to happen, these two need to be the same. They have to go to the same number. So far we have then the limit has to be 3, right? So the limit as the left and the right has to be 3. So a plus b has to equal to 3. And also that limit of 3 needs to be the function value. So a has to be 3. And if a is 3, then a plus b, then b has to be 0. B has to be 0. So that is what we have so far. So then let's rewrite our function just to make sure that we are correct here. So f of x is going to equal to 5x minus 2 for x is less than 1. And then a is going to be 3, x is equal to 3, if x is equal to 1. And then it equals to 3x squared plus b is 0, so just 3x squared when x is greater than 1. So then if we were to check when we are approaching 1 from the left, 1 times 5 is 5 minus 2 is 3. And then f of x, f of 1 is 3. And then when approaching 1 from the right, 1 squared is 1 times 3 is 3. So all of these conditions are met, and that the function is continuous at 1. Okay, that is number 7.